So in this lesson, we are going to be finding the square roots of numbers that have rational square roots. So all of these are going to be perfect squares. Now, even when we get into the homework towards the bottom, where we're going to have some fractions, we may need to simplify those fractions before we try to find the square root. So generally, whenever you're trying to solve an equation like a squared equals b, let's say that our a squared is, let's say it's 7 squared. We know that we could get an answer of 49 by squaring that. If you also did negative 7 squared, this will also give you positive 49. So there are actually two answers to this. It's the principal square root, and then you can also get the negative square root. For our purposes, unless they have a plus minus in front, we're only going to give the principal square root for this. When you do this in geometry, and you're going to be using a lot of radicals in geometry, if it's the measurement of a side length or an angle, we're always going to keep the principal square root or the positive square root. We won't keep a negative answer for a side length. So just keep that in mind next year when you take geometry, that yes, when you square root a number, it could have a negative answer, but in geometry, we usually will get rid of the negative. But when we get back into Algebra 2, we will keep both answers. So here is a property of square roots. All this says is if you have two numbers that are being multiplied, you could actually pull them apart and find the root of them individually. So for example, if you have 4 times 16, instead of multiplying that, you could pull it apart, find the square root of each of the answers individually, and then multiply it by itself. So when we're finding the square root of a number, what we're looking for is what number times itself gives us the answer. Now, this little symbol here that looks like a check mark and almost like a division box, this is called the radicand. So if you ever hear somebody refer to a radicand, that's the radical symbol. The number underneath is the radicand. So when we find the square root of a number, sometimes they'll say the square root is 16 or root 16, and then the answer would be 4 or plus and minus 4 because it's got a principal and a negative square root. Now, when you get larger roots, like on the back here, when they ask you to find the square root of 225, let's say you didn't realize that this was a perfect square, that actually 15 times 15 will give you 225. So what you can do here is you could do a factor tree. So there's two ways to break down square roots if you're not sure if it's a perfect square. Again, if you memorize the perfect squares up to 20, it might help you recognize when you have a perfect square. And what I mean by that is 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, and so on. Recognizing that these are perfect squares, and when you square root them, they will give you a rational answer. Now, 225 is kind of large, and let's say you didn't realize that 15 times 15 gives you 225. What you can do here is do a factor tree, and you can start by dividing it. Now, I could divide this by 5, or if you realize that 25 will also go in here. I know that 9 quarters is $2.25, so I could break this into 9 times 25. And then if you realize at this point that these are also perfect squares, you could just square root them. But I have some students that like to continue breaking it down until you get all the prime numbers. And then anything that you make a pair of, this is a perfect square. Because 3 times 3 is 9, and the square root of 9 is 3. 5 times 5 is 25. Square root of 25 is 5. Everything that comes out, you multiply it back, and the answer is 15. Now, again, in the homework tonight, all of these will have rational answers. So you'll be able to come up with a number times itself that'll give you the number that's underneath the radical sign. Let's try another one. Again, a really large number here. So let's say you don't know what it is. So let's go ahead and start factoring it until we can find some perfect squares. So 2,304. I can start by factoring this, and I could, obviously it's an even number, so I could actually just divide it by 2, and then from there, keep breaking it down. So 2,304 divided by 2, 1, 2, 10, 5, 2. So 2 times 1,152. I got too many ones there. And then keep breaking it down. So again, I could still divide that by 2. If you realize that maybe there's a larger number, that'll go into 1152. Like 4. Let's try 4 into 1152. So 4 will go in here 2 times. And 4 will go into 35 8 times. And then 4 goes into 32 again, 288. So now I've got 4 times 288. I still got to keep going. So I'm going to still keep bringing the 2 down. The 4 will break down into 2 times 2. I could actually break the 288 into 2 times 144. Now, at this point, if you realize that 144 is a perfect square, you could square root it, but I'm going to keep breaking it down till I'm prime. So 2, 2, 2 is still coming down. 144 is 12 times 12. And then, again, you could keep breaking it down. 3 times 4, 3 times 4, and then 2 and 2, 2 and 2. So now I'm going to count how many 2's I have. I actually have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 2's here, and then I have 2 3's. So I'm going to go ahead and try to make some pairs here. So 1, 2, 3, 4, 5, 6, 7, 8, and a 3 and a 3. So I'm going to make pairs. So 1, 2 comes out of this. A 2 will come out of this pair. A 2 will come out of this pair, and a 3 will come out of this. Then you're going to go back and you're going to multiply all these numbers. So 2 times 2 is 4. I could also do a 4 here, and I still have the 3. And then 16 times 3, and I get 48. So the square root of 2,304 is 48. So there's different ways. If you try to find a factor when you first start out your factor tree, that's a perfect square, and you realize and you get a perfect square, you could square root it mid-problem if that's easier for you. So either way, whatever's going to work for you. Now, there's another property, and this is going to be the quotient property. Just like with the multiplication, we can actually pull this fraction apart and square root the numerator separately and square root the denominator separately. So, for example, on part A here, I could pull this apart and do the square root of 36 and the square root of 121. The square root of 36 is 6. The square root of 121 is 11. So that would simplify to 6 over 11. I can do the same thing on part B. I can actually simplify this and do 144 separately, and then the 3,025. Now, 144, everybody should probably remember that 12 times 12 is 144, so that's a perfect square. However, this 3025, chances are you wouldn't know that it's 55 times 55. So what I would do here is I would do the factor tree for 3025. And again, I know I could divide this by 25. So I could do, let's try dividing it by 25. Goes in here once, and then twice, and then one more time. So 25 times 121. And at this point, if you realize that these are both perfect squares, you could square root them and get 5 times 11, and then get 55. And that would be your answer there. Or if you didn't realize they were perfect squares, then you're going to keep breaking it down. 5 times 5, 11 times 11. And then you can see you have a pair of 5s. So 1 5 comes out, a pair of 11s, 1 11 comes out, and you multiply what comes out. So again, it simplifies to 12 over 55. And this had a plus minus in front. So in front of your answer, just put plus minus. So at the beginning part of the homework, all you're going to be doing is finding the square root. So let's practice a few more. So this first one, negative square root of 81. Anybody know what number times itself gives me 81? 9. So notice the negative sign out front. You're going to drop it down, and the answer is negative 9. Let's look at number 3. Anybody know what number times itself gives me 25? Okay, and for this case, we're only going to give the principal, so we're just going to give the positive answers unless there's a negative sign outside. Let's look at number 4. Yes?
There's a plus minus outside.
And you'll also leave that. Leave it as a plus minus. Okay, so for this homework, again, we're only going to give the principal unless there's a negative outside or a plus minus. All right, anybody know what number times itself gives me 144? 12. All right, now, look at number 9. Notice this one, whenever you're squaring a radical, that actually makes the radical go away. Because essentially what you're doing here is the square root of 6, square root of 6. Remember up top where we were doing the factor trees? Whenever I make a pair of these, one of them comes out. Or you could multiply it and get square root of 36 and realize it's 6. But the shortcut, anytime you see a number squared under a radical, the square and the radical undo each other. And then the number that's there just falls out. So you don't have to worry about, like on number 8, doing 52 times 52 and then finding the square root of it. Just know that a square root will cancel out a square. Now, on number 14, again, remember you could pull these apart. Find the square root of 81, the square root of 16, and it's 9 over 4. Now, when you get later on in the homework, you may have to simplify some of the problems because you're actually going to go all the way to number 244 even. Let me come down here and let's look at some of these in the section B here and even in the decimal section. Now, notice on this one, they're simplifying the fraction before they try to find the square root. Now you're doing even, so let me do some of the odds here. So for example, number 21. The answer is 28 over 63. If you realize that 28 and 63 are not perfect squares, but I could actually reduce this fraction, or I could do like they're doing in the sample, and I know that 4 times 7 is 28, and 9 times 7 is 63, then what I could do is simplify, cancel the 7s, and now the 4 and the 9 are perfect squares, so 2 over 3. and it had a negative out front, so put a negative in front of the answer. So when you're doing part B, you may have to simplify the fractions first and then find the square root. Like look at number 23. Notice I could, now if you don't want to factor it, you could also say, I'm going to simplify this fraction. I'm going to divide them both by 11 and make this 9 over 4. And then I can root them separately and get 3 over 2. So you can either simplify the fraction or you could factor it like I did here. Either way. Now, also on here, you can factor this, turn it into a fraction. So this would be 4 100ths. And then again, this is number 33. And then for 33, you would square root the 2, square root the 10, or the 100 and get 10, and then 2/10 is 0.2. So for this section, 33 through 44, your answers will all be decimals. Okay, so you can do it that way, or you could just think of what number times itself is going to give you 9, and that would be 3. So it's going to be 0.3 times 0.3, and that would be 3 times 3 is 9, but you need 2 decimal places, so the answer here is 3/10. So you could either turn them into fractions like they're doing there and then find the square root, or think of the answer by itself and then put in the appropriate decimal point. So that is the lesson on square roots, and these are all perfect squares. So you should not have any square roots left in your answer. Everything will end up being a perfect square. There will be some number times itself that will give you the given problem. Now, next week we will be doing irrational, where we will have to do the factor tree, and part of it will be left under the radical symbol. So your homework for this lesson is 2 through 44 even. So what we'll do tomorrow is we'll go over these answers, and then tomorrow we will do a test review, and then you have your test on Thursday. Any questions?